Hi dear students, welcome here. I am your Bala sir. So now we are going to discuss JEE Main September 2020 CBT based physics question part 2. In this video session we are going to discuss from question number 6 to 10. So totally 5 questions we are going to find the solution. Okay, let's discuss the sixth one. A capillary of radius 0.15 millimeter is dipped in a liquid of density rho is equal to 667 kilogram per meter cube. So, a capillary tube is given, its radius r is equal to 0.15 mm is the radius of the capillary tube, and its liquid density is given, it is 667 kilogram per meter cube. Okay. If the surface tension of the liquid is 1 divided by 20 Newton per meter, then find the height up to which the liquid rises in capillary. Here angle of contact between liquid and capillary tube is 60. So theta is 60 degree, and also we have to choose G equal to 10 meter per second square. This is an interesting problem and it is a straight question. So just we apply the data in the relevant formula. So you know very well the capillary rise. So if you have a liquid in a container, say for example water like liquids, so because the angle is acute angle, so when you insert a tube, capillary tube, what happens? There will be a capillary rise. So this is actually the capillary rise H. This capillary rise depends on some values. This capillary rise depends on the radius of the capillary tube and angle of contact. What is angle of contact? It is the angle between the surface of the tube and the tangent to the meniscus of the liquid, which makes an angle theta here. So for mercury it is obtuse angle, for water like liquids, lighter liquids, we have acute angle theta. Here theta is 60 degree, as you know very well, and also it depends on the density of the liquid, surface tension, and also acceleration due to gravity, everything it depends. So I just write down the formula. H is equal to 2t cos theta is divided by r rho g. This is the formula to calculate the capillary rise. It is a direct formula. You just apply the data, you will get the result. Sometimes they will ask about the surface tension, they will ask to find the surface tension from this expression, and in that case height will be given. Okay, now we substitute here 2 into surface tension 1 divided by 20 into cos 60. What is the value of cos 60? Just keep in mind. And the radius is 0.15 millimeter is 0.15 into 10 to the power of minus 3 into density is 667 kilogram per meter cubes. All are in SI except this. We have converted this into G. G also is taken as 10. Okay, that is equal to, so this is equal to 2 into 1 divided by 20 into cos 60, how much? Cos 60 is 1 by 2, right? Cos 60 is 1 by 2 divided by, this will be 15 into 10 to the power of minus 2, here 10 power minus 3, so you will get 10 to the power of minus 5, am I right? Into 667 into 10, so here 2 is getting cancelled, so you will get 1 by 20 divided, I will write the options, 0.01 meter, 0.02 meter, and then 0.04 meter and 0.05 meter. These are the options you have given. Now you can write 15 into 10 to the power of minus 4, am I right, into 667, right. This is equal to, you bring the term here 10 to the power of 4, or I can write 100 into 100 divided by 15 into 20 into 667, am I right? Okay, so this if you cancel by 20, this will be 5 times. 5 3s are Yes. So 100 divided by, if you multiply, you will get 3 sevens are 21, remaining 2, 18 plus 2, 20. Am I right? So remaining 2, so 2001. I will approximately take it as 2000. So 2 zeros goes off, therefore you will get 1 by 20, and which will be equal to 0.05. Am I right? If you divide by 1 divided by 2, you will get 0.5, which is divided by again 10, so you will get 0.05 meter is the correct answer. So you have to choose option 4. Option 4 is the correct answer. This is about a capillary rise question. Am I right? Just to go through it. So formula we have written, data given in the problem I have written. This is the suitable diagram to understand, and mere substitution you will get the result. That is your solution. Next we will go to problem number 7. So in this problem, an electrical circuit is given, a potentiometer circuit is given. So we have a battery, its EMF is E, which is connected to a potentiometer wire AB. So AB is potentiometer wire, and from the point A we have a EMF epsilon, which its value is given 1.02 volt. Okay, 1.02 volt, and we have another resistor, external resistance R, and the circuit is open here. So which is connected through a jockey through a galvanometer, and this balancing, the total length is 1 meter, you know very well. This is 1 meter wire. So what is the problem says, in the given potentiometer circuit, 1.02 volt is balanced at 51 centimeter. Balancing length is 51 centimeter. So when the circuit is closed, you will get the balancing point at 51 centimeter. That is your balancing length, and the EMF is equal to 1.02 volt. Now they are asking about a potential gradient of the potentiometer wire AB. What is the potential gradient? And your option is 0.01 volt per centimeter, 0.02 volt per centimeter, then 0.3 volt per centimeter, then 0.4 volt per centimeter. Okay, now let me write down this expression for potential gradient. Potential gradient is nothing but potential per length, potential difference per length, potential gradient, or change in potential with respect to the change in distance. That is called a potential gradient. So when you choose this balancing length, the corresponding length is for the potential difference 1.02 volt. So it is nothing but V by L. So V is 1.02 divided by 51 centimeter. So if you divide by approximately, if it is 1 by 50, so it is 1 by 5 means 0.2 divided by 10, you will get 0.02 volt per centimeter. So all options are volt per centimeter. So option 2 is the correct answer. This is also a very simple question for you. So you can easily find out the solution. Yes. You understand, boys? Okay. Next we go to the question number 6, 7. We have to see now question number 8. The question number 8 is, in hydrogen atom, electron jumps from n plus 1th state to nth state. Electron, this is n plus 1th state, this is nth state. Electron jumps from n plus 1th state to nth state. So that, what is the frequency of the emitted photon? That is the question. The frequency of the emitted photon is proportional to what? That is the question. Your options are options are n, 1 divided by n, 1 divided by n square and 1 divided by n cube. Okay. This is what the options given in the problem. Now let me write down the energy associated with an electron in any energy level. Energy of nth level is equal to minus 13.6 divided by n square electron volt. This is the energy of electron at any energy level. Okay. Now we have two energy level. One is nth level. Let it be equation number 1. And for n plus 1th level, the corresponding energy will be minus 13.6 by n plus 1 the whole square electron volt. Am I right? And this energy difference when electron jumps from higher energy to lower energy, that energy level will give you photon of energy h nu. So energy difference E n plus 1 minus E n is equal to h nu. Am I right? Okay. So h nu is equal to E n plus 1, this is the first term, and this will be minus of minus, this become plus. So 13.6 by n square minus 13.6 by n plus 1 the whole square. Right. Okay. Energy also will be electron volt will be cancelled. So 13.6 the frequency divided by h into 1 by n square minus 1 by n plus 1 the whole square. Now simplify this expression, you will get 13.6 by h into cross multiply n plus 1 the whole square minus n square divided by n square into n plus 1 the whole square. Am I right? Okay. This will be equal to 13.6 by n into 13.6 by h into, you just expand it, n square plus 2n plus 1 minus n square, which is divided by, again you will get okay. The condition is n is far greater than 1. So hint is given, n is far greater than 1. So divided by n square into n plus 1 the whole square. Okay. So here I can cancel this term, n square. So your answer will be 13.6 divided by h into 2n plus 1 divided by n square into n plus 1 the whole square. Am I right? Okay. In this condition, n far greater than 1, you can ignore the term 1 as well as if you multiply before expansion, if you expand this you will get n square term, right? N square into n square, n power 4. You can choose this term only, even I ignore the n cube term. So that in numerator I will retain this term n 2n, and denominator I will retain the term n power 4. Okay. So 1 n is getting cancelled. So you will get 27.2 divided by h into 1 divided by n cube. So this is a constant. Therefore our frequency is directly proportional to 1 by n cube. So option 4 is the correct answer. Okay. Option 4 is the correct answer. The frequency of the emitted photon is directly proportional to 1 by n cube, or inversely proportional to n cube is the correct solution for this problem. And let me go to the another problem which is in simple harmonic motion. This is also a very important problem. You follow this? You understand this? Yes. Problem number 9. So the problem number 9 says displacement time graph of a simple harmonic motion. Displacement time graph of a particle executing simple harmonic motion is shown in figure. The diagram is like this. So x axis time and y axis we have displacement x. The graph is like this. The graph is like this. So here the time period is t by 4. Here the time period is t by 2. Here it is 3t by 4, and here the total time period is t. Okay. 3t by 4, and here, so up to this the graph is over. Fine. Okay. find the four options are given, of which we have to find out which one of the statement is correct. So the first statement I will write, no force acting on the particle at t by 4. No force acting at t by 4. Option statement B is speed of particle is maximum at speed maximum at 3t by 4. Third statement is acceleration at t by 4 is maximum and last third statement is kinetic energy and potential energy is equal. Kinetic energy is equal to potential energy at t is equal to t by 8. T by 8. These are the options. We have to choose which of the following statements are correct. Maybe one statement may be correct or more than one statement may be correct. So we have to check each and every statement. Let us check first. No force is acting at a point t by 4. So what is this point? This point is, so when this particle is executing simple harmonic motion, this is one extreme position, this is mean position, this is another extreme position, this is mean position. So then it is go to another mean extreme position. So wherever the particle cuts the x-axis, it is at a mean position. In mean position, the acceleration will be 0 at t by 4 as well as 3t by 4. When acceleration is 0, what is our force? Force equal to ma. So definitely a equal to 0 means force equal to 0. So therefore the statement 1 is correct. Okay. Then I come to this speed maximum at 3t by 4. So force 0 and the speed is maximum at 3t by 4. Here acceleration is 0. So in this case, okay, speed is maximum at 3t by 4. When the speed is maximum and it is a constant, then acceleration will be 0. So at mean, say for example, if you take one pendulum which is executing simple harmonic motion, this is original position. If it is going to this extreme position, when it is accelerated towards the mean position, here the speed will be maximum. Okay, and then it goes to another extreme position, it comes back. So this is one complete motion. So here t by 4, here t by 4, here t by 4. When 3t by 4, the particle will be in the one of the extreme position at which the speed, so here the speed is maximum at 3t by 4 means, so here one position, second position, third position. So in third position what happens? Actually this is for particle executing simple harmonic motion from rest, but our problem starts from the one of the extreme position. So we have to start from here. So for us this will be t by 4 and this will be another t by 4, total time period t by 2, and this will be t by 4. So for us this position is again, so again the particle comes to the mean position at which the velocity is maximum. Therefore the statement B is also correct. Now the option C, let me check. Acceleration at a t by 4 is maximum. So what is your t by 4? T by 4 already we have said the acceleration at t by 4 is 0. So maximum cannot be accepted. So this option is wrong. And finally we have to check the option D, kinetic energy. What is kinetic energy and potential energy? Kinetic energy of simple harmonic oscillator is half k into a square minus x square, where a is amplitude, a square minus x square, and that is equal to half k into x square. K is m omega square, which is a constant. So you can cancel it. So a square minus x square is equal to x square, or 2x square is equal to a square, and x square is equal to a square divided by 2. Therefore your x is equal to plus or minus a by root 2. That is your displacement. Now let us go to time. At what time this happens? We know that x is equal to a sin omega t. This is the displacement equation for a simple harmonic oscillator. So x is equal to a by 2 if you choose, then a into sin omega t you will get. So a is cancelled. So sin omega t is equal to 1 by 2. For what angle sin theta becomes 1 by 2? Yes, for 30 degree, right. So omega t must be, because sin 30 is 1 by 2. So omega t is pi by 6. Now omega is 2 pi by t. It is for angular frequency into time is equal to pi by 6. Therefore pi is getting cancelled. Now we have to find out a by but we should be very careful. This equation is only for particle starts from the rest, start from the origin, but our problem starting from the positive y axis, that is from one extreme position. So we have to choose x is equal to a cos omega t. Here we have to be very careful. So x is equal to a by root 2 and a cos omega t, right. So a is getting cancelled. So cos omega t is equal to 1 divided by root 2. Am I right? So this is for 45 degree. So cos 45 is 1 by root 2. Similarly sin 45 is 1 by root 2. So omega t is equal to, so you will get pi by 4. Now 2 pi by t into t is equal to pi by 4. So pi is getting cancelled. Therefore our t is equal to, this t comes here, t 2 into 4 8. So at this time t is equal to t by 8, our kinetic energy and potential energy will be equal. So this condition is also satisfied. So three options, three statements are correct, A, B, D. Your options I will tell you. The first option is B and D correct. Second option is A and C correct. Third option first option is A and C correct. Second option A, C and D correct. Third option A, B and D correct. Fourth option is C and D correct. So for us A, B and D correct. So third choice is the correct option. Third option is the correct solution for this problem. So we have to check each and every statement, and finally we have to choose the result. So this is very time expensive problem, so we have to do very quickly. Okay, then last problem, 10th problem. A closed box contains an ideal gas. If temperature of a gas is increased, which of the following is correct? So a closed container, this is problem number 10. Okay, so let me discuss the problem number 10. A closed container gas, a closed container having gas, its temperature is increased, so that what happens to the following? Your options are mean free path same, this is the first option, and B is mean free path decreases, mean free path decreases. Option C, relaxation time decreases, relaxation time decreases, and statement D is relaxation time remains same. Relaxation time remains same. These are the statements. Your options are B and D correct, A and C correct, A and D correct, A and D correct. Fourth option is B and C correct. These are the options. We have to check each and everything. What is mean free path? Mean free path is nothing but the average distance between the two successive collision is nothing but mean free path. Its value is given by 1 divided by root of 2 into n by v pi d square. So, we have to explain the each and every term, where n is the number of atoms, v is the volume, and d is the diameter of the atom. So, number of molecules, n represented by number of molecules, v volume of the container, d diameter of the molecule, and here there is no specification about the temperature, right. So, when you increase the temperature, nothing will happen about this mean free path. So, this statement will be correct. And mean free path decreases. So, it is not depending on the temperature. So, nothing will happen. So, this will be wrong statement. And here the relaxation time decreases. When you increase the temperature, what will happen? Number of collisions will increase. So, when the number of collision is increasing, the relaxation time will decrease. It will not take rest. It will fastly collide with the successive molecules. The relaxation time in fact decreases, that does not increase. So, decreases statement is correct. Remains the same is also not correct. Therefore, options A, statements A and C are the correct statements. So, the answer is AC is correct. Second choice is the correct option for us. So, we have discussed here 5 problems in the part 2. So, totally we have discussed 10 problems. Remaining 10 problems we will discuss in the forthcoming videos. So, keep watching. So, if you have any doubt or any clarification, you write your comment in the comment box. Okay. Please subscribe, keep supporting. Thank you.